Okay, day 17, about to start. We have opcodes and stuff. Initialize the registers to the given values. Okay. Uh, comments. Oh boy. Okay. Does it end? Uh, halts. How does it halt? Oh, I see. What's going on? Going through numbers pretty fast. One one 7 4 4 0. Oh, something went wrong here. Hmm. And solve this? No one has solved it. Interesting. We need to actually read the program, huh? Uh, okay. Seems relatively clear. So, this is 1, 2, 4. Hmm. Still no solves. Be some like octal number, right? Four, five, seven. C, A, 2B. Yep, it's absolutely not what it is. is the right answer, though. Okay, that was interesting. Okay, so what happened here? That was pretty slow in part one. Okay, so we're given this program to run, uh, which is like this little I don't know. Yeah, it's this little language, little VM. So there are three variables, A, B, and C. And then there's this little string of, I don't know, 20 or something digits, which gives you a little computer that you can run. So we have to implement the computer. Um, so there's 8 different opcodes, and each opcode takes one argument. And so you have like your current position in the program, right? So we're like executing this program, which is a string of 20 digits. So we have a current position in the program, and if we run off the end, then we're done. And if what? So there's 8 possible commands. So we read like the current digit, and if it's a 0, that means do some command. If it's a 1, means some other command, so on. So 0 means A equals A uh, int mod 2 to the combo argument of the next, always the next character is the input. So maybe I should have like saved that off. Maybe that's nicer. So I guess there's like 2 modes to read the input, which is either you can just read the number, or you can get this like potentially read a register. So if you see 4, 5, or 6, that means A, B, or C. Um, so this is combo mod 8. And after every instruction, you move the current position in the program forward by 2. Uh, this one actually doesn't take an input, but it still skips forward by 2. Okay, so what are these things? Right, A divided by 2 to the combo, B is combo mod 8. This is a jump instruction, so change where you are in the program to a little between 0 and 7. This is B is B XOR C. This is actually output something, which I guess matters for the problem. This is combo mod 8. Yeah, I should change this to print out part 1 as well. And command 6 and 7 are the same as command 0, except they write to B and C instead of to A. So, these are the 8 commands. Wonder if this still runs. It's not. Uh, oh, I see. The point is that we're only allowed to, well, just do this. We're only allowed to like look at a combo operator if it's not 7, I guess. So anyway, like the commands that take a literal operator can take a thing that's not a valid combo operator. So I had some assert that tripped, but okay, we'll just say that this is like invalid. Um, okay, so anyway, in part one, you're supposed to run the program and print out just the list of outputs, comma separated. So maybe I should make a helper function, which is like, just runs it. And maybe returns the list of outputs. So I think that should give you part one. And then for part two, if we just want that, let's see. Uh, oh, I see. I don't know. Is that an important optimization? It probably is. So the exit thing. I feel like this is running really slow now. Seems bad. Ah, I feel like I broke it. Okay, well, while this is going, let me talk about what I did for part two. So I tried to like manually figure out what this program was doing. I mean, it's not that long. It's literally 8 instructions long. And you can kind of see that it's kind of extracting things from A mod 8, right? So it like reads a base 8 digit from A, and then it like skips the next digit. And here it's like reading some bits out of A, um, sort of further back. And then I don't know, it does some like little modulo stuff and it outputs a digit. So like you can see that the base 8 representation of A is going to be relevant. Uh, and you can also see that like once A is big enough, like the output values only depend on the first few digits of A. Like the first output value only depends on the first few digits of A mod 8. Because B is at most 8, or at most 7 here. Um, And we only care about C mod 8 here. So that's what, like 10 bits? So this is, I don't know, whatever, like 3 or 4 digits of A. So once we find a value of A that spits out the right, like, first couple digits, we know that those are going to be the lower bits of A. Oh, I broke something. That's unfortunate. So that's basically what I did, is I brute forced like an A that gives you the first few digits that you want, uh, and use that to brute force like the next few digits, and then use that to brute force the next few digits, and that was enough to give me my answer. But why is this slow now? I do not understand. It's not really slow, I guess, so much as it's not working. Six two three 6017. Oh, I see. Okay, so I think that is fixed now. 765365704. Cool. So that prints out the right answer for part one. And I believe this also prints out the right answer for part two. 190 something something 823. Yeah, cool. So you can see I'm like brute forcing the last few digits of A here. Well, I don't know, the last half of the digits actually, but it seems to run pretty fast. Um, is there like a nicer way to do this? Let me just clean this up a little bit more. I probably just want to return out here. Cool. Okay. So in part two, I guess I never explained what part two was. Sorry for this explanation. In part two, we're supposed to output the original program. Uh, so, um, as I mentioned, I sort of decompiled the assembly and noticed that it cared about A in base 8. So I did some brute forcing to, like, let's just reconstruct this. So we can do some brute forcing to get like A's that give you the first few digits correct. And we can see kind of here, it seems to be ending in like 36017. So let's assume that those digits are right. And instead we'll just brute force over like the next digits. So that got us up to like 8 digits. Okay, we're getting some more digits. This gets us up to 10, 11, and what can we see? We have maybe 236017. Well, that was pretty stable. Can we assume that like 7? It's a little sketchy to do this pattern only on 2 things, right? But maybe we can assume that these are the right digits since they matched 2 in a row. And this is how many digits? I guess this is 9 digits. This is what I did to actually solve the problem. So like let's assume that those trailing 9 digits are correct and see if we can brute force any more digits. And it turns out that they are, and we can pretty rapidly brute force the rest of the digits and get a final answer. So I don't know. That's kind of the pattern that I went through to eventually solve this is like print out the digits mod 8 or in base print out the like we want to brute force A's that reproduce some prefix of the program, right, as much as we can, and print them out in base 8 and like see which digits are stable because we know that the output should only depend on like the first few digits. And then we can once we're happy with like the last 5 digits, then we can search through digits like 6 through 9, and then once we're happy with digits 6 through 9, we can search through the rest of the digits. Uh, okay, and we can suppress this output, and now we just get the 2 answers to the 2 parts of the problem. Okay, so that was a very long explanation. I wonder if other people have solved it by now. Not quite. Okay. But that is it for today, and I will see you tomorrow.